Okay guys, so I'm not feeling all that well, but I'm gonna try to show this to you. I'm doing it from home, so I'm using a tablet and my Blue Snow microphone. See how this goes. So we're talking about periodic functions in this unit, and as you can see from this graph, periodic functions are things that repeat themselves. Now all these are curves, but it doesn't have to be just curves. There's a pattern that repeats itself over and over. So let's start by thinking about what everyday things actually are periodic. So what things repeat themselves? Well, we have like the days of the week. They go Monday, Tuesday, and repeat itself again. The whole 7 days, right? And I guess on time-wise, we have like the seasons and the days of the years and the months. They repeat themselves. So all that time stuff repeats themselves. We can probably say that the heartbeat, when it's a constant heartbeat, we're not getting more excited. It's fairly periodic too. It happens over and over. If there's a rock in your wheel or in your tire, and that happens and you go into this constant speed where it goes tuck, 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 that kind of stuff. The height of a person in a Ferris wheel, well, that's going to be going on this kind of a cycle, so it's going to be looking like this, right? The tides also are fairly periodic because they go up and then go down, they go up and then go down, and that has to do with the rotation of the moon and the rotation of the earth. And basically everything that rotates will have some sort of a periodic function because it will be repeating itself over and over. So a periodic function is a function that has a pattern of y values that repeats at regular intervals of its domain, because domain was all the x's, correct? Some definitions here. Cycle, one complete pattern of a periodic function. So I really want you to think of, whenever you hear cycle, it's a shape. So cycle is actually the shape. So in this case, the shape of this graph, well, I could start it anywhere because it doesn't really matter because it repeats itself. So if I say it starts here on top, this is one cycle, right? But I could start it here in the middle, and this would be one cycle, right? Or I could start it at the bottom, or I could start it halfway. Doesn't matter. I think of a cycle as a stamp. So if you think of a stamp for a pattern, you can just go stamp, 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 and create that thing that goes over and over. So again, the cycle is just the shape. So the most common cycle for this kind of shape, it starts here in the middle. But that's not always the case, so that's just how we did it. Period is the horizontal length of one cycle. So in this cycle starts right there and it ends about there. So it takes this many degrees for this thing to turn around. Well, this is something that's turning, so it's obviously going to be 360. What about the amplitude? This is weird. It's the distance from the middle to the max or the min, or half the distance from the max and the min. So I already put, let me just do the axis of the curve first. The axis of the curve, it's this guy right here. This line right through the middle. So halfway through the top and the bottom. So if I put a line, this is going to be hard because I don't have a horizontal thing, but if that's bad. If I try to go a straight line through the top and a straight line through the bottom, better. The axis of the curve goes right through the middle. Okay, so, and that has an equation that's y equals something. In this case, it's y equals 1.5, right? Well, the amplitude is the distance from the axis of the curve to either the top or the bottom, because it's going to be the same distance, right? Because it's halfway through it. So it doesn't matter where you have it. The amplitude is the distance from the top to the middle, not the bottom. Okay? So the cycle, period, amplitude, and shape. So here are some examples. Let me just do a couple. Let's do this one. So if I want to do, I have to mark one cycle on the graph. Well, that's one shape. And again, I could start it anywhere. So I'm going to do this. Is that one cycle? Well, no, that would only give me the U part, so I need to get this top part over. That's one cycle, right? Or I could have started from here. Just make sure you have the right thing. So I marked one cycle. What is the period? Well, the period goes from here all the way to here. That's 1, 2. That's 2 units, right? So the period is 2 units. What's the amplitude? Well, before I do the amplitude, let me get the axis of the curve. So I'm going to do the top part, the bottom part, that's the minimum, and now the line in the middle. I'm going to use red for the axis of the curve. So between 1 and 4, well, that's going to be 1.5. So this is y equals 1.5. And that's the axis of the curve. So y is equal to 1.5. Oh, and I think I had this. Yeah, so I could actually grab it and take it. Let me see if I can do it again. There, set around 1.5. Does that make sense? So the period is 2 because it takes 2 units to complete one full pattern. The amplitude, I haven't done it. I'm going to do it in black. And it's from the middle to the top, except that I forgot to select the right tool. So from the middle to the top, and that's, well, also 1.5 to get confused. Amplitude is 1.5. Notice that the equation of the axis of the curve has to have an equation, so it's y equals 1.5. But these guys are just numbers. Let's do one more. Let's do this on top. So again, mark one cycle on the graph. Well, I'm going to use this cycle. I'm going to use a V in honor of Victoria. But I really could have just started here and make it like the round one from before. If that's the V, now let me just mark one cycle. It goes from here to here, and that's from 2 to 6, so that the period is 4 units, right? Okay, now I'm going to mark the top, goes through 3, and the bottom goes through -1. Therefore, the axis of the curve is right in the middle. See if I took that one. No. So, is that the middle? Yeah, 2 about. Okay, that's the axis of the curve. So the axis of the curve is y equals 1. And now the amplitude is from the middle to the top or the bottom, and that happens to be 2. So the amplitude here is 2. Does that make sense? Try the other ones. Try the other 2, and the answers are on the PDF that's posted on the website already. So here it said, create 2 periodic functions of your own given the following information. Mark one cycle on the graph, period of 6, amplitude of 4, equation of the axis of the curve is -3. It's usually easier to start with this. So I'm going to mark y equals -3. So -3 is there. So that's my axis of the curve. And now I'm going to go to the amplitude. So the amplitude is 4, so I'm going to go 4 above. 1, 2, 3, 4. I'll mark it here. And 4 below. 1, 2, 3, 4. And now near the period of 6, which means that every 6 this pattern should repeat itself. I don't know what it is. I guess the easiest thing for me to graph would be just a straight line. So that's what I'm going to do right now. So let me grab black. And if I go from 10, it should repeat in another 6, so it should repeat here. And it should repeat another 6, another 6. So I'm going to do, and it has to reach the top and the bottom. So the simplest thing would be to just say, I'll go all the way like this. And now like this, and like this. So see, that'll be a cheesy one. But the right one, the period is like that. If I didn't want to be so cheesy, all I had to do is just create something else. So let's say I'm going to go up and go 2 over, 2 over, 2 down, and then 1 across. So that's my cycle, right? So I had to mark it with my highlighter, and then do the same thing. I just repeated 2 over, 2 over, 2 down, and 1 over. I think I counted wrong, but you get the idea. Just repeat the pattern. Excuse me, and then you get your shape. Okay. And here was this is my friend Dave, and it's a joke that I borrowed from Mafalda, but here are the questions that you should have worked on at school already. I hope this made more sense, and I will see you soon or on the next video. 10 minutes.